Hello everybody, welcome into another lesson. So today we are going to continue what we did yesterday with fractions, adding and subtracting them, but we're going to deal with mixed expressions. What do I mean by mixed expressions? One such as this, where you have a whole number or a regular number and then you have a fraction. Well, of course we have 8 plus 1 over x. If it helps you, you don't have to. Just know that 8 has a default denominator of 1. This would be the same as 8 over 1 plus 1 over x. Now, between 1 and x, you need to find the greatest common, or the least common denominator, which would just be x. Well, what you're going to have to do to get 1 into x is multiply by x, which means you got to multiply the numerator of 8 by x. You would have 8x in the numerator, plus you already have your least common denominator with 1 over x, so you'd have 8x plus 1 over x. Which, when we go ahead now, we can do the addition. You'll end up getting 8x plus 1 over x. And that would be your answer, would in fact be 8x plus 1 over x. Pretty simple, right? Simple enough. Alright, let's see. We have 3 plus 7 over a. I think I'll get back to using green for the next steps. Okay, 3 plus 7 over a. Well, you can rewrite this as 3 over 1 plus 7 over a, because anytime you have a whole number, the default denominator is 1. Now, between 1 and a, we got to find the least common denominator. Well, that would be a. When you have 3 here, in order to convert that 1 into an a, you just got to multiply 1 by a. You'll get a as your denominator, but you got to do it to the numerator too. You would end up getting 3a. So you have 3a over a plus 7 over a. Now you have the same denominator. You can add these. You would just end up getting 3a plus 7 over a. And that would be your final answer, would be 3a plus 7 over a. Alright, 3a minus 2 all over a. So now we have 3a minus 2 all over a. Well, that 3a still has a default denominator of 1, so we can write it as 3a over 1 minus 2 over a. It's good to have a guiding 1 if it helps you. You can have a guiding 1 in your denominator. Well, between 1 and a, we need a least common denominator. That's definitely going to be a. In order to convert that 1 into an a, we have to multiply by a. You would have a in your denominator, which means you got to multiply that numerator of 3a by a. That would give you 3a squared. Then you just have minus 2 all over a. Now you have the same denominator. You can go ahead and do the subtraction. So the answer you should get would be 3a to the second minus 2 all over a. So you'll get 3a to the second minus 2 all over a as your answer. Alright, we have a over b minus 3. Alright, so we have a over b minus 3. Well, that 3 can still have the denominator of 1. So this could be a over b minus 3 over 1. Now between b and 1, the least common denominator is definitely going to be b. So a over b already has that least common denominator. We can leave that alone. But in order to convert that 1 into a b, we have to multiply by b, which would give you b. But we have to do it to the numerator of 3. That would give you 3b. Now we have the same denominator of b. We can go ahead and do the subtraction. A minus 3b, well, it is just that. A minus 3b all over b. And that would be your answer, would be a minus 3b all over b. Alright, we have 5 minus 4 all over x plus 2. So now we have 5 minus 4 all over x plus 2. Well, that 5 has a default denominator of 1, so we can write that as 5 over 1 minus 4 all over x plus 2. Alright. Well, between 1 and x plus 2, your least common denominator is going to end up being x plus 2. So, in order to convert the 1 into x plus 2, we just have to multiply by x plus 2. And in fact, that's what you'll get for your denominator is x plus 2. But what you do to the denominator, you got to do to the numerator. You'll have 5 times x plus 2. So you'll have that minus 4 all over x plus 2. Now, before we do the subtraction, I think it's safe to say we should do the distributive property with the 5 times x plus 2. If we do that, you'll get 5x plus 5 times 2, that's 10. Then you have the minus 4 all over x plus 2. Well, if you simplify this, you'll still have 5x. 10 minus 4, that's 6. So what you should get is 5x plus 6 all over x plus 2. So your final answer for this should be 5x plus 6 all over x plus 2. Let me get some different markers here. Let me grab some different markers. Let's see here. Bear with me a minute. I'm going to grab some better markers. I thought the ones I had would last through the lesson, but apparently not. Alright. So there's that problem. Alright, we have 8 plus y all over y minus 1. So we have 8 plus y all over y minus 1. Well, that 8 definitely has a guiding denominator of 1, so we can work with that. We have 8 over 1 plus y all over y minus 1. Well, least common denominator of 1 and y minus 1 is definitely going to be y minus 1. So in order to convert that 1 into y minus 1, we got to multiply by y minus 1. If you do that, you'll end up getting y minus 1, but you got to do it to the numerator of 8. Multiply that by y minus 1. Then your second term, the y over y minus 1, already has the least common denominator, so we can leave that alone. But before we do the addition, let's do the distributive property on 8 times y minus 1. If we do that, 8 times y, well, that's 8y. Then you have 8 times negative 1, well, that'd be negative 8. Then you have plus y. All that all over y minus 1. Which now we simplify this. 8y plus y, that's 9y. Minus 8, all that all over y minus 1. So the answer you should get is 9y minus 8 over y minus 1. Alright, let's see here. We have 4 plus, and we have 2n plus 1 all over n plus 1. So we've took it up a notch. We have 4 plus, and we have 2n plus 1 all over n plus 1. Well, that 4 has a denominator of 1, so let's work from there. So you have 4 over 1 plus 2n plus 1 all over n plus 1. Well, least common denominator of 1 and n plus 1 is in fact going to be n plus 1. So we need to convert that 1 into an n plus 1. You just got to multiply by n plus 1. If you do that, you will in fact get n plus 1. But you got to do it to the numerator, so you would take 4 times n plus 1. Now, your second term already has the least common denominator, so we can leave that alone. The 2n plus 1 all over n plus 1. So before we do any further addition, let's do the distributive property on the 4 times n plus 1. You would end up getting 4n plus 4 plus 2n plus 1 all over n plus 1. Which we simplify this further. 4n plus 2n, that's 6n. 4 plus 1 is 5. You would end up getting 6n plus 5 all over n plus 1. That would be your answer, would be 6n plus 5 all over n plus 1. Alright, let's see. We have 6x minus x all over x plus 1. So 6x minus x all over x plus 1. Well, that 6x has a denominator of 1. Let's start with that. Then minus x all over x plus 1. Well, your least common denominator of 1 and x plus 1 would for sure be x plus 1. So we need to multiply that 1 by x plus 1 to turn it into that least common denominator. So we've done that now. Denominator's x plus 1, but you got to take that 6x and multiply that by x plus 1. Then the second term, the x over x plus 1, we can leave that alone. That's already got the least common denominator. So now we have 6x times x plus 1 all over x plus 1 minus x all over x plus 1. Well, let's do the distributive property before we do any further subtraction and addition. So 6x times x, that's 6x to the second. Then 6x times 1, well, that's plus 6x. Then you have minus x. All that all over x plus 1. Which, to simplify this further, you would get 6x to the second plus 5x all over x plus 1. You can leave your answer like that if you so choose. If you want to get technical, you could factor out an x in the numerator. You would have x times 6x plus 5 all over x plus 1, but nothing factors any further, so there's really no point in doing that. 6x squared plus 5x all over x plus 1 is perfectly acceptable. Alright, we have 4y plus y all over y minus 5. So now we have 4y plus y all over y minus 5. Well, that 4y has the default denominator of 1. Let's go ahead and work with that. So you'd have 4y over 1 plus y all over y minus 5. Well, your least common denominator between 1 and y minus 5, that's going to be y minus 5. So let's go ahead and convert that denominator of 1 into y minus 5. We just went ahead and did that now. But you got to do it to the numerator too, so you'll take that 4y, multiply that by y minus 5. Then your second term, the y over y minus 5, already has that least common denominator, so we can leave that alone. Okay, so before we go any further, let's do the distributive property on the 4y times y minus 5. If you do that, 4y times y, that gives you 4y to the second. Then 4y times negative 5, that's negative 20y. Then you have plus y. That all over y minus 5. Simplify it one more time, you would end up getting 4y to the second. Now negative 20y plus y, that's negative 19y. So you get 4y squared minus 19y all over y minus 5. And that would be your answer. It would be 4y to the second minus 19y all over y minus 5. Okay. Let's see here. 2a to the second minus a plus 1 all over 2a plus 5. Alright, so we got 2a to the second minus a plus 1 all over 2a plus 5. Well, it's safe to say that 2a to the second has a denominator of 1. So let's work with that. So you have 2a to the second all over 1 minus a plus 1 all over 2a plus 5. Well, we need to make the least common denominator is definitely going to be 2a plus 5. So let's go ahead and convert that 1 into a 2a plus 5. So we've done that, but now we have to take that 2a to the second, take that times 2a plus 5. Then your second term, that a plus 1 all over 2a plus 5, we can leave that alone because that's already got the least common denominator. Alright, so before we go any further, let's do the distributive property on the 2a to the second times 2a plus 5. If we do that, you'll end up getting 2a to the second times 2a, that'd be 4a to the third. Then you have 2a to the second times 5, that'd be plus 10a to the second, minus a, minus plus 1, that's minus 1. You would end up getting 4a to the third plus 10a to the second minus a minus 1 all over 2a plus 5. And that really doesn't simplify any further. That does not simplify any further. So your answer is 4a to the third plus 10a to the second minus a minus 1 all over 2a plus 5. Alright, any others I'd like to do? Alright, let's do some multiplication ones here. Let's say we have x plus 4 times the quantity of 4 all over x minus 1. So how in the heck are we going to approach that? Well, we're going to use the classic FOIL method. Okay? You have x plus 4, that quantity, times 4 all over x minus 1. Well, first start out with your x times your 4 over x minus your x times 1 plus 4 times 4 all over x. Then you have 4 times negative 1, that'd just be minus 4. So we've done the foiling. Well, x times 4 over x, the x's cancel, you just got 4 minus x times 1, that'd just be x. So you have 4 minus x plus, let's see, 4 times 4 over x, that'd be 16 over x. Then you got minus 4. Well, let's hang on here a second. We have 4 minus 4. Your constants go away. What you really have are negative x plus 16 over x left, or you could just do 16 over x minus x. You just have those left. You've reduced it down to a much simpler problem. So now we just got to find the least common denominator of x and 1. Well, the x is over 1, right? That denominator would be x. We can leave the 16 over x alone. That's got the least common denominator. Minus, okay, 1 times x is x, so the denominator just became x. We got to take that x and multiply that by x, which would give you x to the second. So now we can do the subtraction. You'd end up getting 16 minus x to the second all over x. And you can leave your answer like that. Can you technically factor 16 minus x squared? Yeah, you would get 4 plus x times the quantity of 4 minus x, but that x in the denominator is not going to go away. So why do the extra work? That don't make any sense. The answer you get is 16 minus x to the second all over x. let's see. We have a plus 2 over a, that quantity, times a minus 2 over a. Well, does this not look like a factorization of a binomial square? It certainly does. We can take the shortcut, since you have 1 plus 2a and 1 minus 2a, you would end up getting a squared minus 4 all over a squared. That's going to be your binomial square. It beats foiling. You could save yourself some foiling. So now we're reduced to, we got a squared minus 4 all over a squared. Well, what we have to do now is find our least common denominator. Well, the a squared has a denominator of 1, right? That means our least common denominator is a squared. So, if you multiply 1 times a squared, you get the denominator of a squared. That means you have to do that to the numerator also. A squared times a squared, well, that's a to the 4th. Then you have 4 over a squared. You can leave your second term alone. So now you have the same denominator. You can do the subtraction. You would end up having a to the 4th minus 4 all over a to the 2nd. And that would be your answer, would be a to the 4th minus 4 all over a to the 2nd. Alright, let's see. We have 2x plus 3 all over x times the quantity of x minus 2 all over x. So we got to do our foiling here. You'll just take your 2x times your x. Then you have plus 2x times negative 2 all over x plus 3 all over x times x plus 3 all over x times negative 2 all over x. So there's the foiling for that. Well, 2x times x, that's 2x to the 2nd. Then let's see, you have 2x times negative 2 over x. Well, your x's will cancel. You just get 2 times negative 2. That'd be negative 4. Then you have 3 over x times x. Your x's will cancel. You just have plus 3. Then you have 3 over x times negative 2 over x. Well, that'd be minus 6 over x to the 2nd. Alright, well, we could simplify this before we do anything with denominators. Negative 4 plus 3, that's negative 1. You'll end up having 2x to the 2nd minus 1 minus 6 all over x to the 2nd. Well, we have 3 terms, but we're still going to do it the same way. Your 2x squared has a denominator of 1. Your negative 1 has a denominator of 1. So between 1 and x squared, we need to find the least common denominator. That would definitely be x squared. Let's convert the first term, that make that denominator x squared. We'll do just that. Well, 2x squared times x squared is 2x to the 4th. Then you take that 1, make that x squared for your next term in the denominator. Then 1 times x squared, well, that's x squared. And then you have your 6 over x squared. Well, that doesn't factor any further. We can't do anything with that because it's already got the least common denominator. So now we have the same common denominator of x to the second. We can do the subtraction, which would give you 2x to the fourth minus x to the second minus 6 all over x to the second. And that's as far as it goes. That's really as far as that goes. 2x to the fourth minus x to the second minus 6 all over x to the second. All right. Let's see. We have m over n minus n over m. That quantity divided by let's see, 1 over m plus 1 over n. Alright, so now we got some division. First thing I would do, and your order of operations dictates this, is deal with your parentheses. Deal with each of the parentheses individually. So, only consider this first part here, the m over n minus n over m. Your least common denominator of n and m would be mn. Well, to make the first denominator nm, we got to multiply by m, which would give you mn, but you got to do it to the numerator of m. You multiply m by m, you get m to the second. Alright. Well, now, in order to make the second denominator of mn, you need to multiply by n. You would get mn. Well, it means you got to multiply the numerator of n by n. You would get n to the second. Alright, so now we've established a least common denominator between the first two terms of mn. Now, still on the divided by, you have 1 over m plus 1 over n. Well, the least common denominator of m and n would be mn. So, in order to make mn, you'd have to multiply by n. You would have mn, but you got to multiply that 1 by n. You'd end up having n. Plus, now you have 1 over n. You need to make that denominator mn. You got to multiply by m. Which you do that, you would get mn. Multiply the 1 by m, you get m. Alright, so now we've at least established common denominators in each of these terms. Well, let's go ahead, deal with the each of these parentheses still. We'll have m squared minus n squared. All over mn. That divided by n plus m is the same as m plus n. All over mn. Alright. Alright, well, now, let's see here. With the division, we can invert and multiply. So you're going to end up having your m squared minus n squared all over mn. You're going to take that, but with division you invert and multiply. M plus n over mn would invert to mn all over m plus n. Well, notice your mn's cancel out. What you're left with now is m squared minus n squared all over m plus n, which we know m squared minus n squared, it does factor further. You would have m plus n times m minus n all over m plus n. Well, between the numerator and denominator, the m plus n's cancel out. All you're going to get for your answer is m minus n. And that would be your final answer, would be m minus n. So, probably starting to see where everything we've been doing up to this point is really starting to come together. That's why if you are struggling with a previous concept, there is no shame in it. Please feel free to go back and view any of my previous videos. That'll help you. And it'll cover it in more depth with whatever you're struggling with. Alright. One more and then we're done. We have 1 minus 2 over a divided by 1 minus 4 over a to the second. Alright, so again, deal with your parentheses, take each of these individually. Let's start with your first set, 1 minus 2a. You need to establish a least common denominator. Well, the least common denominator would definitely be a. You would end up, for 1, you would end up getting a over a minus 2 over a. That would be divided by, let's deal with your second one now. You have, let's see, 1 minus 4 over a to the second, while your least common denominator would be a to the second. So for the 1, you would end up getting a to the second over a to the second. Then you have minus 4 all over a to the second. Alright, now in each of these individually we can do the subtraction. You'll end up getting a minus 2 all over a. That would be divided by a squared minus 4 all over a squared. Well, since we have division, we can invert and multiply. So your first term, the a minus 2 over a, well, that's going to stay the same. A minus 2 over a, that doesn't change. But your second term, since it's division, you're going to invert and multiply. You would end up having a to the second all over a squared minus 4. Okay. Well, that a squared minus 4 definitely factors further. You'd end up having a minus 2 all over a times the quantity of a to the second all over the factorization of a squared minus 4. That would be a plus 2 times a minus 2. Well, we notice here between numerator and denominator, a minus 2 cancels out, so that makes life a little bit easier. Then between the numerator and denominator, you have a and a squared. Well, a is a factor of a squared. Divide a by a, you get 1. Divide a squared by a, you get a. So what you should be left with in the end would be a over a plus 2. And that would be your answer, would be a all over a plus 2. So that's it for this lesson. Next lesson, we are going to move into some polynomial long division, which is actually kind of fun and cool. So I hope everyone has a good night. Take care.